So we are from group 5. So we are assigned to do a construction of a new dam for 30 km square of reservoir at Malacca. So the first objective for our project are to expose the Sbeu first year student to the process in conducting the engineering survey project, from producing the survey job specification until the final report submission. And the second one is to give the Sbeu first year student more understand how to deliver and implementing the various of engineering survey project. So we will go to introduction. There is many types of dam, such as arc dam, buttress dam, coffer dam, diversion dam, embankment dam, gravity dam, hydropower dam, and industrial dam. So the most suitable dam that suit for our construction was arc dam. So what is arc dam? An arc dam is a concrete that is curved upstream in the plan. So we can see in the figure that the middle in the dam is curved and upstream inside until the other side. So why the arc dam is designed like that? Because the arc dam is designed so that the force of the water against it, that known as hydrostatic pressure, that press against the arch to straighten slightly and strengthening the structure as it pushes into its advancement. So last, why do we choose arc dam? Because they are thinner than any other dam type, and last, they require much less construction material, that making them economical and practical in remote areas.
This project is conducted to produce a survey job description of the construction of a new dam for the 13 km squared of the reservoir area at Malacca. This project includes the reconnaissance and hydrographic survey as well as the marking of tentative alignments. This project takes place at the reservoir area at Malacca. Reconnaissance survey, tentative alignment marks, and hydrographic survey, the geophysical information and all of the necessary dimension, angles, and elevations are needed in this project before the physical surveying has begun. We will start with the marking of tentative alignment. When the site of the dam has been selected, the tentative alignments for the canals are selected. These alignments should be marked in the topographical and contour maps. In the reconnaissance survey is conducted for all of the alignments that has been selected. This survey will provide a magnetic bearing of lines of the traverse along the alignment, past records of floods, and suitable cross drainage works. Hydrographic survey is also used to gather critical data to model and analyze the conditions around the dam. These models is then used to calculate the volumetric quantities of scar holes, voids, and sediments buildup to a high degree of accuracy. During the surveying of the dam, pillars are constructed on both banks of the river. Similar pillars are then constructed to mark the center lines of the headworks for both bank canals. Soil boring is done along the center line of the irrigation structure to determine the depth of the foundation. A permanent benchmark is created and its value is connected to the nearby GTS benchmark. Plane table survey is conducted on both sides of the alignments and route survey map is prepared. Longitudinal survey and cross-leveling is conducted. Then permanent benchmarks are arranged with some interval gap along the alignment. At the river crossings, the cross-section details of the river that are taken on both upstream and downstream sides are noted. Finally, drawings are prepared for all of the survey maps and cross-sections where the engineers will use them to create the dam.
This is the drawing of our dam. As you can see, upper left is the view from the side, and upper right is the view of the dam from the top, and bottom left is the view from in front of the dam. The length of the dam is 1 kilometer. And last one, the view from cross-section. The height of the dam we assume to be 100 meter. Why we build 100 meter? Because the height of the water is 90 meter. So if it rains, the height of the water will be increased. That's why we decide to do 100 meter.
This is our methodology for project 2. First, we have to diverting the river. Second, we have to preparing the foundation. Next, we have to build a concrete dam. Then we have to pouring the concrete. Next, we have to build an embankment dam, fill the reservoirs, testing the valves and floodgates, and last we have to monitor the behavior of the newly built dam. Diverting the river, River have to be diverted to create a dry area to construct the dam through a tunnel that was constructed around the site of the dam. A dry construction pit is formed on one side of the river, leaving the other side open for the water to flow through. The first portion of the dam was constructed in the dry pit. When it is finished, another dry area is formed on the other side of the river, and the remaining part of the dam is built. The river flows through opening in the completed portion of the dam, and the reservoirs can start to fill behind it. Second, preparing for the foundation. Soft soils and rock are excavated to form the roots, while harder rocks have to be blasted and explosive. Excavated and blasted with explosive to remove weak soils and rocky area because foundation must be strong enough to withstand the weight of the dam and the water pressure acting on the dam. Remove and replace weak soil and rocky area below planned foundation to stronger material because some rock foundation have cracks. Drilling a hole in the rock, then pumping the grit into it and spreading it outward to fill the cracks. Fill them with grit to prevent water from leaking through the cracks in the reservoirs. Third, build a concrete dam. Build concrete batching plants on the construction site. Mix a lot of concrete mixture in this building in the way for making a concrete dam. Pouring the concrete. Pouring a wet mixture of concrete into a formwork made from sheet of timber. Let the concrete dry before next section. Spreading the dryer of mix of concrete and compact it down using roller compactor concrete dams. Form low concrete walls on upstream and downstream faces of the dam to form the edges. Transported concrete to the area between the walls and spread it in a thin layer using bulldozer. Drive the rollers over the concrete to compact it down on top. Transfer the concrete from the batching plant to the dam use system of conveyor belts. The concrete is taken by trucks to the bottom of the dam where it is poured into skips which are lifted to the top of the dam by cranes. Fifth, building an embankment dam, constructed outward in a series of thin layers, the fill material is transported to the dam by trucks and dumped there. Spread the material in a thin layer using bulldozer. Compacted downward fill layers are above and fill layers using rollers. Form a protective layer on its upstream face. This layer protects the dam against damage by wave and sometimes provide waterproofing. 6. Filling the reservoirs. Fill in the dam reservoirs dam constructed when the river's flow is low. Testing the valves and floodgate works. Lastly, we have to monitor the behavior of the newly built dam.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Fizani bin Razali. So this project 2, I will talk about the survey instrument and software that we use in this project. So we use total station and leveling. Total station or total station theodolite is an electronic or optical instrument used for surveying and dam construction. By using this total station, we can calculate or measure the data of arch, area and height of the dam. These are some of basic component in theodolite such as telescope, level bubble, phase, triback, optical plummet, horizontal circle. This is an example of picture of total station. Next we go for leveling. Leveling is a measurement process whereby the difference in height between two or more points can be determined. So in this project, this method provide the height of the dams. There are some of the instrument or component in transportation and leveling, such as telescope, level bubble, dryback, optical plummet, tilting, level, automatic level, digital level, laser leveling, tripod leveling staff bubble, base or change plate. So here is a sample of leveling tutorial. So last but not least, software that we use AutoCAD. AutoCAD is a computer design software developed by the company Autodesk. We refer to use AutoCAD because it allows us to draw and edit digital 2D and 3D design more quickly and easily than we could do by hand. So by using this software in this project, we can create our own idea on how the design of the dams that we want to do. So it will help us with our project more faster and so efficient, because we can just directly convert our idea to computer rather than by drawing by hand. That's all for me. Thank you.
So we will move to the conclusion. The design of ArcDam is an iterative process that requires consideration of numerous factors, such as topography, geological and foundation conditions, which are the volume change of the ground due to the climate conditions. The third is availability of materials, spillway size and regression, earthquake, and height of dam. It is critical to truly investigate these issues, as each one can have an effect on the design and results, and may even necessitate changing the dam shapes. That's all from us. Thank you.